Done. And we are live. So thank you very much for coming along to this month's Not IoT. It's great to see everybody. I hope you had a great summer. Obviously, we've been away for a little while now. In fact, I've kind of paused most of my community work in the meantime, in between sort of July and today. So it's nice to get back to this. This obviously we've been streaming on the IoT live channel a couple of weeks now, but yeah, it's great to be back. So before we get going, we do have a code of conduct, and we take this quite seriously. So if for any reason you feel as though you're being made to be uncomfortable by any other person, then either send me a message at Pete_codes on Twitter, or even better, if you could do it on Zoom as a direct message, then we'll take this seriously and make sure that everybody feels welcome and safe in our meetup. So if you want some more information about that, then you can hit that bit.ly up down there. So Not IoT Be Nice. It's worth having a read through that and just making sure that you adhere to the standards we're expecting from our attendees. So with that out of the way, we've got our sponsors. Soon, I'm hoping we'll go back to in-person, actually, although obviously, like most meetups, we'll have some form of hybrid for that. Most likely, we'll have a mix of in-person speakers as well as remote speakers, as well as in-person attendees and remote attendees. So it's going to be quite difficult to get that to work properly. I'm hoping that it's not going to be as hard as I think, but this is hard enough. So I'm imagining that's going to be quite complicated. But either way, my company, PJG Creations, I'm a consultant, so I do software for money, essentially. That my company on there is sponsoring it because I'm organizing the meetup and doing all the social stuff and hosting websites and stuff. So that's why my logo was on there. Tech Nottingham on the right, they sponsor us our Zoom license. So you're here courtesy of them, which is really nice of them. And there's a slide next, which will talk about them slightly at that point. JetBrains, they're sponsoring us a free 12-month license to one of their products, and I'll talk about that shortly as well. And stickers, they're a sponsor we've had for a while, but actually we've not been able to give out our stickers, and hopefully when we go back to being in person, we'll be able to do that again. So that's our sponsors, and thanks to them for making this meetup happen. I mentioned on the previous slide about Tech Nottingham. So they're a Nottingham-based community for everybody in an IT area. Not necessarily a programmer. You can be an ops as well, eh, Johnny? Perfectly feasible for you to join. And in fact, they're not just Nottingham-based anymore. They're worldwide, like every community is these days. But they've got channels in there from everything from the standard general channel to a jobs channel to a channel talking about PHP and Devops. They've pretty much got everything. Even if you want to count up in hex, then there's a channel there for that. It's really good. The whole community's awesome. Ran by Andrew Seward and Louise Paling and a whole heap of other people involved in that organisation are doing a cracking job. So thank you for the Zoom license to them. If you tweet on the hashtag #NotIoT tonight, then one lucky person, in fact, there's a good chance that two lucky people will win a JetBrains license, which will give you a license for one of any particular product from JetBrains: Rider, ReSharper, IntelliJ, WebStorm, PHP Storm, all of those excellent products that JetBrains make. It's well worth tweeting on that to get yourself one of those licenses. And in fact, I'm pretty sure that Alan Buxey's here, so you most likely end up with another license, Alan. But yeah, so I think I've got a few stacked up, so there's a good chance that there's going to be two given away. Most likely I'll do it after the event, but either way, there's a good chance of winning that. So do tweet on the hashtag #NotIoT. Tonight, we have got the excellent Johnny Chips, or John Lunn. Most people know him as Johnny Chips, I think. Speaking about AIoT and exploring video analytics at the edge with Azure. And in fact, I wanted to keep putting words on the end of that, but the title got too long. So there's everything in this talk. It's awesome. And John does an amazing job of cramming it all into the time he uses there. So it's well worth sticking around for that talk. It's going to be cracking. So coming up, meetings next month, we've got John Staveley talking about how he's built an automated bird watching system using a Raspberry Pi. So I've seen a lightning talk version of this talk, and it was really interesting. And I was sort of helping him along with some of the stuff to get it working. So it's a really cool project that he's got working there, and another AI focused talk. So well worth checking that one out. And that's on Thursday, the 14th of October. And normally we'd do the third Thursday of every month, but the third Thursday of next month is in the middle of half term. And I would have got told off if I was trying to arrange a Not IoT in the middle of that. So that's why it's the second Thursday. I hope that doesn't impact with the Welsh Azure user group there, Johnny. I don't know what time.
We've moved to Wednesdays now, Pete. You're all right.
Oh, have you? Oh, so how good are you? I like that. I like it.
Especially for you.
Thank you. If you want to do a bit more AI, then I've got a Percept in front of me, and I'm giving a talk about how we can do Alexa-like work with the Percept audio module, so that we can, well, in my particular demo, I've got a Raspberry Pi that can turn a lamp on and off. So that goes through from the Azure Percept audio module through the carrier board up to an Azure function, and then out to an IoT hub, and then from the IoT hub down to the Raspberry Pi that's got a relay connected to it, a mains relay that's controlling a lamp. So there's quite a few moving parts in that, and this will be the first time I've given this talk. So come along and see if I can make many mistakes while giving this talk. I've got a bit of practicing to do before Monday, but that's Monday, September 20th from 5 o'clock BST. I'll be on Twitch, I think, that one. So check that out. Also, at the end of this month, we've got Chris Reddington from Microsoft coming along to talk about requirements, design patterns, cloud architecture. Oh my, all the different things you need to take into account when you're thinking about the cloud. So Chris is a fantastic speaker as well. It'd be well worth coming along to that. So that's Monday, September 27th from 6:30. And then Devops Nuts. Devops Nuts are fantastic meetup. They're back from their summer break as well. And they've got Simon Prickett from Redis talking about an introduction to Redis and Redis streams. If you want to take your IoT learnings a bit more professional, then myself and a few other authors have created a learning path for the AZ220 Microsoft Azure IoT Developer Certification. And you can go and learn as much as you like in that course. It's got 5 stars all over the place, so the whole course is awesome, not just my little part of it. And if you need a 30-day code, all access 30-day code to Pluralsight, then hit me up and I can get you one of those as well. And we mentioned there briefly about IoT Live. So myself, Cliff Aegis, and now a brand new host in Maria Anastasia Mustaka are talking about IoT mostly on Tuesdays at 9 p.m. BST or GMT, depending on where we are. BST at the moment. Very informal show, just going through a bunch of stuff that we've found over the course of the week and chatting about IoT generally. So yeah, that's well worth tuning into on the Azure-ish Live Twitch channel. And hopefully we'll be bringing back the Azure-ish Live main show soon as well, once Liam's arm has healed. Liam Gulliver, one of the main hosts, decided that he was going to pull tricks on a BMX and fall off it and break his arm, bless him. So that's what he's been doing. And if you're interested in agile engineering or DevOps in general, then myself, Liam Gulliver, and a bunch of other people host an agile engineering podcast. Louise Paling, Misha Bell, Jonathan Ralph, all those people. Fantastic show. And with that, I will stop waffling and we will do the switch over to Johnny Chips to start his talk. So at this point, obviously, we're still on YouTube, but make sure your microphones are muted. If you've got any questions, then stick them in the chat at that point. And if there's an opportune moment, then I'll interrupt Johnny as he's doing it. If not, then we'll save them till the end of the presentation and we'll go through them then. If we get much past about 8 o'clock during this presentation, and again, no one's going to clock watch during this time, but we'll probably have a short break and let people have a bio turn around. But yeah, enjoy the talk and thank you very much for coming along.
Thanks, Pete. Yeah, thanks for having me. Can you hear me okay? And can you see my screen, I suppose, is the most important thing.
Indeed.
Cool. Okay. So yeah, hi, everybody. Yeah, wow. Okay. So yeah, going to do this talk again. I've only given this talk 3 or 4 times now, but it's like having a mentor and a master as well. All these people on this call at the moment. I'm talking about 2 people who are on the call. It's like, no
we
pressure,
love you, Johnny.
John.
We love you,
no
Johnny.
pressure, no pressure. So, okay. So a little bit about me then. So, yeah, my name's John Lunn. I work for BT Enterprise here in the UK. I'm a technical architect, so I kind of in cloud solutions. So I kind of help BT Enterprises customers do all that good stuff about transitioning and modernizing their applications and all that good stuff into the cloud. I was recently awarded the Azure Mvp status, which I was pretty humbled by. It's pretty cool. I got a blog and all that good stuff, but I've also got more slides for some shameless self-promotion because, you know, what would a user group be without some shameless self-promotion? So I kind of got this YouTube channel where I do weekly updates on Azure. I do In Conversation With series where I pick on some cool advocates or technical representatives or students from across the industry and have a chat with them once a week. So go and check that out if you can. Also got the blog, you know, who hasn't got a blog these days? Mine's johnnychips.com. So lots of ramblings and bits and pieces on there for you to go and have a little look-see. And I'm also co-organizer of the Welsh Azure user group. So once a month, the usual format, we've been virtual up to now, as everybody will know. We're actually doing our first in-person event in about 2 weeks' time, the end of September. So that's enough shameless self-promotion. On with the talk at hand. So yeah, I speak to Pete and you know, probably got about 45 minutes to an hour. We got Mr. Paul DiCarlo on the line as well. And I was just saying before we went on that everything I'm about to run through at the minute, I think when Paul did it originally, I think he had this statement where it took about a year's worth of his knowledge and learnings that he crammed down, and he actually created like an 8 or 9 hour video series with how to configure all these bits and pieces together. And I guess I'm trying to cram it down into a 45-minute or an hour chat. So it's interesting. It's always interesting. So there's the agenda. So basically, we're you know, just going to set the scene. Why have you got me, Johnny Chips, on to, you know, Not IoT, to talk to you about NVIDIA, you know, object detection and video analytics using edge devices and kind of using the cloud to kind of enable some of those data insights and visualizations. Well, we'll get to that in a second, but we're going to look at an overview solution. So the point of this talk is that we look almost like nuts and bolts, you know, from soup to nuts, I should say. So from the physical device right the way through to kind of the end, potentially production-ready solution. However, you know, there's a bit more to it than that. So yeah, we're going to cover these areas in a little bit more detail as we go through. Like I say, there's lots to get through, so I'll do my best to kind of set the level as appropriate as I can. But before we jump in, bit of scene setting. You got this man to blame, really. I think it's probably fair to say, Pete, I found the most good-looking photo that I could of you.
Yeah, so, that was a while back. That was. Holy cow! Look at my hair color.
That's good. That's good. You know, I've not quite gone that grey. You know, but. No, on a serious note, I mean, you know, as I was explaining to Paul and Pete again before, so I work in operations sort of role, and I have done for sort of, you know, close to 20 years, I guess. You know, I've got a little bit of development background, and, you know, I know enough code to be dangerous, but over the last couple of years, and certainly, you know, over the last 18 months, you know, looking into the world of IoT and machine learning and AI and things like that, it's kind of really sparked and reinvigorated my passion to kind of get back to what I remember doing when I was a developer all those years ago. I think, you know, it's like that reinvigorating the spark. And, you know, obviously Pete knows how much I think of all the stuff he does with Cliff and, you know, the guys over at Azure Live. So you've got this man to blame why I'm here talking to you. So it's really about my story of, you know, how I've kind of used this particular, and see Pete coming on camera there, use this particular sort of end-to-end solution. And it really has reinvigorated my kind of passion for tech. So when I was watching one of many of Pete's videos over the last sort of 18 months, one of these things popped up on the screen. Now, I've been dabbling with the Raspberry Pi and an electronics kit and things like that, and making LEDs blink and flash and writing a bit of Python or C# and putting it onto a board. And, you know, I noticed one of these things pop up, and I think Paul was a guest on the Azure Live channel probably a good year ago now, I'd imagine. And it sparked my interest. You know, what is this? And off the back of that, Paul actually announced that he was running one of the NVIDIA the Deep Learning Institute has got this course, kind of, you know, like an introduction to this thing called DeepStream SDK, which was really all around video analytics and using edge devices to kind of analyze video, real-time video, whether that's live video stream, whether it's pre-recorded video, but using these really, you know, simple entry, you know, simple to get into the market, really, you know, low cost devices very similar form factor to the Raspberry Pi, but with it being made by NVIDIA, you've got this huge capacity of GPU on that board, which is great for kind of parallel processing of things like real-time video. So I thought I'll go and buy one. So I bought one, and me being me, got a little bit of a setup at home. I started doing the thing. I found that I really got into it, set my little camera up there. So, I'll just point it out that I bought a couple of little Wi-Fi cameras. I don't know if that's coming up on the screen there. No, it's not, is it? There we go. No, that's not. I'm circling the camera.
Yeah, I can see the camera.
There we go. There we go.
It's fine.
So little Wi-Fi cameras off Amazon. And there's my little Jetson Nano box that I bought off, I think it was off Amazon, actually. I may have bought that. So I started going to town and started really trying to follow some information and trying to see what we could do with this. And as it happened, because Paul had caught my eye with some of the stuff he was doing, I managed to join his course. And like I say, Paul's on the call, Pete's on the call. With those two guys, kind of led me down this path. So me being me, posted these photos up on social media, interacting with Paul, understanding all the stuff that Paul had worked through in this 8-9 hour video series. I thought I'm going to give that a go, because to me, as an operations person, it was more about that end-to-end solution, the joining of the dots between a solution to kind of go from not just having, a board or flashing some LEDs or doing something, simple, but actually to make that device talk through an end-to-end solution and actually get something meaningful out the other end. And it's nothing more, but purely for learning activities. So Paul hooked into it. Like I say, I had a quick chat with Paul, and it kind of went from there, really, and hence why I'm giving this talk. So AIoT. So what is AIoT? So artificial intelligence of things is a combination of AI technologies with the Internet of Things infrastructure to achieve an efficient IoT operation, improve human-machine interactions, and enhance data management and analytics. Lots of words there, but to me, it's about being able to run those really clever, intelligent workloads, those AI machine learning models on, in this case, which I'm about to get into, a really small, low-powered PC or low-powered computer, but actually do some analytics of that data or whatever it is that you're doing. In this case, it's going to be object detection in real-time video, but do all of that processing on an edge device, but then stream something from that device up to cloud services, and for onwards, picking up some insights and getting some real life data and information from that you can kind of visualize. So that's pretty much what I'm about to run through. So that was kind of like 5 or 10 minutes or so of precursors. So hopefully you got a bit of an idea of what we're about to get into here. So from a solution perspective, the parts that we're going to talk about, anybody that knows anything about IoT knows that it's great. You can make anything that you like. Anything that knows anything about the cloud knows that it's great, but there are lots and lots of moving parts in there. So how do you decide which parts to use to make the solution that you actually need to do? And we all know that there are certain components that could absolutely overlap in features and functionality. So for me, it was a good idea to kind of just narrow down what it is we're actually going to look at today. So first and foremost, the first thing that we're going to look at will be the IoT Edge device. So what is that IoT Edge device? In our case, it's going to be that Jetson Nano. Next thing we're going to look at is really, how do you kind of control that IoT Edge device? And, there is an IoT Edge device SDK. There's a couple of SDKs that can be used to kind of program. We're not going to get into that too much. We're going to talk about the DeepStream SDK rather than the Microsoft SDKs at the moment. I'm not going to dig into it in too much detail. But fundamentally then, the IoT Edge device talks to the central component, which is the IoT Hub. So you can imagine the IoT Hub as that bi-directional, centralized, messaging platform, essentially, that can send and receive messages from an application or service or device. And it's there to be stored with, and then you would use something else to move that message into another area of your particular end-to-end solution. So in this case, the other components we're going to look at are stream analytics. So how do we essentially use that data stream of whatever that data is that's coming out of that edge device? Why might we want to use stream analytics? What is the purpose of stream analytics, and how does it fit into a solution? We're going to touch on that slightly. when it comes to kind of visualizing the data, can we do something quickly? Can we visualize data, relatively quickly with a pre-built solution, essentially? And that's where time series insights comes in, especially if that data is timestamped, and hence the name of the service, time series insights. So we're going to have a little look at that. We're going to then move on to actually using Power BI and this particular end-to-end solution, looking at how you can stream that data out into data sets and then use something like Power BI to start really, quite simply visualizing, and gaining meaning and insights out of that data, and creating custom, custom dashboards with, some good visualization, bar charts and pie charts and things like that. See how we go for time. There's a little element here where we talk about storage. Whether I dip into that or not, I'll keep an eye on the clock and see if we've got time to do that. But another component that we're going to look into may be the storage area. But you can see we've got this whole plethora of other features and things that we absolutely could use in an IoT solution. But for this particular story, I thought it was important to kind of highlight the components that we were actually using in this solution. So hopefully people can start to understand how you can join the dots up between these particular features. Okay, so first off, right, what is IoT Edge? So fundamentally, in this case, it's a small computer. It can be a large computer. It can be any size computer that you want, fundamentally. But for this example, it's a relatively small, low-power computer that's got a price point of around 60 or 70 pounds, which is the Jetson Nano. But like I say, an IoT Edge device is some kind of compute power. Now, what makes it an IoT Edge device is effectively you've got this thing from Microsoft called the Azure IoT Edge runtime, which actually gets installed onto that computer. And that runtime effectively runs a series of what is seen in this image as modules. Effectively, they're interchangeable with containers. So if you're familiar with Docker containers, that is effectively, what is running on this IoT Edge runtime. But fundamentally, an IoT Edge device is around collecting, one or more devices, information, messages, and there could be various reasons why you're doing this, from wanting to keep data local, from a geographical or a site perspective, for various reasons, for latency reasons, for sensitivity reasons. But fundamentally, the IoT Edge device is this compute that takes messages from various sensors, information, sensors and machines, or whatever it may be that you're looking to glean that information from. In our case, it's going to be a couple of Wi-Fi cameras. So with that information, the whole point of the IoT Edge device then is that it does stuff. It can do whatever it is that we want to do with it, what modules we want to put onto it. And we're going to dip into that a little bit just to kind of show a little bit of a taster of that. But once we've done that, we then fundamentally send some messages up to this thing in the cloud called Iot Hub, which sounds great. So that's what IoT Edge devices are at a very sort of high level. The way that they message each other, the protocols that are used to send those messages between either between devices and IoT Edge devices, or even between those modules, those containers internally, it can use a number of different protocols. Again, I'm not going to dwell on it too much, but just understand that we've got a few different options when it comes to actually messaging in terms of what protocol we use, and they tend to fit the kind of device that you're going to be using, which message protocol you might want to use. So, for example, with an edge gateway, something that's got a reasonable level of compute power, you might decide to use AMQP because it's capable of kind of multiplexing messages coming from lots of devices and lots of sensor information in order to do something with and send it onwards. If you are using maybe a resource-constrained device like a small board or a small IoT device, you might find MQTT might be best suited. And then finally, if all else fails, there's always HTTPS that we can use. And obviously anybody that knows anything about networking internally with businesses, generally speaking, opening anything up other than, sort of 443 outbound is generally, seen as a little bit of a security risk. So all of these protocols will also run over 443. So MQTT and AMQP will also run over WebSockets if needed. Okay. Moving on. So the Jetson Nano device, like I said earlier on, it was really the entry point to buy one of these devices in the UK was around 60, 70 pounds. I actually went and bought the 2 gig version. And you can see that it's actually, it packs quite a punch. Mine has got 2 gig of RAM. You can buy the 4 gig version. And I know NVIDIA have got a few different developer kits that kind of go up in size with I think it's the Xavier range and onwards and upwards. But for the purposes, I wasn't going to go and break the bank. I didn't even know if I could get any of this working, or certainly where it was going to lead to. So I went out and bought one of these things. You can see 128 core Maxwell GPU on this device. And just a word of warning, the thing gets hot as soon as you start running any kind of a load through it. So if you do buy one, go and get a little bit of a case and a fan and make sure you plug it in, because, you know, I learned the hard way and took a few layers of skin off my fingers. But yeah, you know, it's quad core ARM based chip on there. Like I say, mine's a 2 gig version, and you know, so on and so forth. Effectively, it's a small mini computer that's, you know, very, very similar form factor to the Raspberry Pi. In fact, I think the GPIO kind of arrangement is pretty much identical. If you do need to do any of that expansion and have GPIO pins for anything other than, you know, just doing some kind of an IoT Edge thing. In this instance, I'm not using any of those pins. It's purely just sat there on my desk doing some compute with something that sat on it in one of these modules. So with that being said, I'm going to quickly talk about actually what is running on this device before we kind of delve over and have a look at it in and poke around at it and see what it actually does. So the first thing to realize is that NVIDIA have released this SDK called DeepStream, which is essentially, you know, the building blocks to be able to actually build applications that can actually do some of this video analytics application that you might want to do. There's a couple of links there that I highly recommend. Now, I did try and find the link to the course that Paul DiCarlo ran. I'm not sure if they're still doing it anymore, or if it's not. I couldn't find it on the website, but go and take a look at getting started with the Jetson Nano, with AI on the Jetson Nano. And also a good thing to look at is the developer guide for the DeepStream. And we'll take a quick look at the developer guide when it comes to actually showing you some of the configuration in a second. But like I said at the start of this presentation, you know, personally, I'm not a developer. So when it comes to things like SDKs and programming and software development, you know, I kind of grimace slightly and think, okay, I can probably find my way around. But fundamentally, the one thing to understand is that this DeepStream SDK, it does come with pre-baked in sort of sample applications, which is great for me, and it's great for anybody looking to get started and up and running pretty quickly without really worrying too much about the back end development. Although, you know, clearly having that knowledge is going to be beneficial to you. So fundamentally, the SDK is really about being able to develop applications to take feeds from any kind of sensor information for various verticals, you know, and use an edge device, or whether that be, you know, I mean, it's listed on-prem here, but it's my little Jetson Nano in my instance, and, you know, do the whole end-to-end solution that we're trying to do, stream that data up to the cloud and do some alerting analytics and data visualization on it. Under the hood, it's a layered sort of series of SDK, you know, built. You can build applications either using C or C++, or you can use Python if you need to. But like I say, you know, from the point of view, and the DeepStream SDK has kind of been developed with QDirects, which really enables you to take the full power of the actual hardware that it's built upon. So you can see that, you know, things like the Jetson Nano there as part of the NVIDIA computing platform, it's, you know, it works. It's been designed and it can use the Jetson Nano and the full capabilities of the hardware that come with those devices and other devices. You can see that on that slide. But like I say, fundamentally, the DeepStream SDK comes with a whole bunch of sample applications, and that's what we're going to take a look at today. And I'm going to give you a little bit of a flavor for what that might look like. So this is kind of like a high level view of what's known as a pipeline. So essentially, when we look at taking video feeds, however that may be, maybe it's an RTSP stream, maybe it's a recorded video file, whatever it may be, it takes those feeds in to this pipeline, and every stage of the pipeline is built from a different part of the SDK and using different libraries of the SDK to do different things. But fundamentally, you can see the first part is that we're using this to decode video. So we might decode that video coming from multiple streams or multiple different types of video file, and, you know, to decode them to a common standard, whatever that may be that you're looking to work with. That then gets passed through down the pipeline into a multiplexer, which essentially, you know, can look to stitch those images together into one image that we can do something with. Once we've got that image of maybe it's one or more camera feeds, It then goes, gets multiplexed together, pushed down to the next part of the pipeline, which is really the inference. This is where our AI machine learning model comes into play. And we do what is known as the primary inference across that image. So essentially things like, if I'm scanning that image or doing some inference on an image, can it detect a person? Can it detect a car? Can it detect whatever it is that you're looking to detect? Great, that's a primary inference. We move down into tracking. If we need to track objects around that particular image, there's another set of libraries for that. Before, we could even include, if we wanted to, a secondary classifier, which could be, right, I've detected a car, what is the make and model, what is the color of the car? So basically the SDK, builds up a series of these libraries that we can use to build our own applications. If you're not a developer like me, great, no problem. You can use the sample app to kind of just get up and running, get things, to a point that you can start to play around with a few things. So, okay, so what I'll do now at this stage, I'll jump on over to the desktop quickly, just to kind of show you what this DeepStream SDK might look like in terms of, what are we actually talking about? So I'm going to jump on over firstly to my Jetson Nano. So there it is. So I'm set up with the Jetson Nano on the desk. I'm just taking HDMI feed, and I think I probably need to do a talk on how I've got this set up to do a talk. It's a little bit complicated, but that is running on a separate PC, or a separate compute. It's got the NVidia Jetpack installed. That's the operating system that's installed. That's how it comes out the box. If you download the Jetson Nano, install it on a 32 gig card, you'll fire it up and it'll look like that, which is great. So it's not doing anything at the moment. So what we will do then is, I think what I'll do is I tend to show Bully special prize so that we can at least then talk about it as we work through this. So if I fire over to the desktop for a second, I'm SSH'd onto the Jetson Nano at the moment. So I'm actually logged in through my Windows terminal, so I can actually start to poke around at that particular device. Now, remember, this is going to be our Iot Edge device. So the first thing that you're going to need to do is go and set that device up in your Azure portal. You're going to have to create an Iot Hub, which I've done all this. There's a lot of steps that I've already done purely to save the amount of time that it takes to actually walk through and do this stuff. So the first thing that you're going to need is an Iot Hub, which if you've got an Azure subscription, you can get one set up. You can see I switched this all back on earlier today, and you can see I'm starting to get some messages through purely for the purposes of this discussion today. If we flick down to Iot Edge, you'll see I've already pre-provisioned a device in there, which is called John Jetson. And to add a device, it's relatively intuitive. You click on there, you can add your device, you can take your device keys and go and connect another device up to this if you like. But most importantly, once we've got this device set up and hooked up to our Iot Hub, this is where you can start to see, like I say, Bully special price. So let's just look behind the curtains at what we're about to start getting into. I've already pre-deployed all the relevant modules that we need to actually get this solution up and running. So the first thing to just check using this screen here is that this is fundamentally what you see running. These are all our modules, our Docker container images that are actually running on that Iot Edge device. And you can see straight off the bat with Iot Hub, you get these two system modules first and foremost, which are the agent and the hub. They just enable the communications back to Iot Edge, Iot Hub in the cloud, and send messages using the Iot Edge Hub module. They come as standard. They'll always be there for any Iot Edge device that you're going to configure. But I've got these four custom modules on there, which I can't highlight. But I'm probably not going to use the screen much more going forward, other than just to show you that these modules are all there. I've got a couple of errors. That's by design. I forgot to mention first and foremost, if I go offline, I'm on a backup phone here, so I'll jump on there and I'll be back with you fairly soon. I won't go into why, but there's a little bit of a bug that I've got at the minute in my setup. So fundamentally, we've got these four container objects running on the Jetson Nano at the moment. So that's great. We can see that the Jetson Nano is running, at the minute, it's running this thing called Azure Blob Storage on Iot Edge, and we've got this thing called the camera tagging module running at the moment, which, look, we'll get into. We'll have a quick look at those in a second, actually. But for now, I just wanted to show you that they were all running. Now, back to my Windows terminal. I'm actually running on my Windows terminal here. I'm SSH'd in. So if I were to do using the Iot Edge Agent, you start to use these Iot Edge commands to actually see what's running. And you can see that my agent is running, my hub is running. You can see I've got those 4 modules, much in the same way as we've just visualized them through the web portal there in Iot Hub. Now, for the purposes, you would normally have all of these images running. And then, like I say, the reason is because for whatever reason, I'm maxing out my Jetson Nano. And when it goes pop, which I have had it do, it takes my Wi-Fi out for some reason. I've not really been able to figure out why. So hence my backup on my 4G network here on my phone. So I've got those stopped. So I'm not really kind of pushing it to its limits at the moment. So first and foremost, hopefully that makes a little bit of sense. If I were to, for example, fire up the particular IoT Edge modules that will actually be my NVidia Jetson, my NVIDIA DeepStream application, which I will do here in a second. So I'm just going to stop the camera tagging module and the other module for a second and just start up my NVIDIA DeepStream SDK and also the DeepStream Analytics modules. So these are the 2 modules that fundamentally make the video analytics work. And we'll dig into how it works now. So I just fired them off on via SSH. So if we flick back through to the Jetson Nano, in a second, we should start to see something happen. And whilst you're doing that, I'm going to flick over to the logs area here on the screen so we can kind of flick between them and see what's going on. So any moment now, I can see that the GPUs have fired off in anger. And there we go. We can start to see something happening on the screen. It takes a moment or two to kind of actually get itself working. But whilst I tell you what, whilst we're waiting for that to come up, I'm going to fire back over to the desktop and you can see that fundamentally, I've got 2 video streams, which I probably should have showed you first. So I've got 2 cameras, one facing, this is a live camera feed, an RTSP feed facing the street where I live at the moment. And this is a camera, it's got a little bit of a lag in it, but this is a camera that's sat there on top of my PC in the corner of the office. These are the 2 raw video feeds. So at the moment, this is what is getting fed into that application that we're firing up on the Jetson Nano at the moment. So we'll see what it does with that. So if I actually delve into the right container, so I'm just looking at the logs there. And again, if I flick back over to my Jetson Nano, you can see that something's happening now. So this is the application running. It's actually taking those 2 raw video feeds, those 2 RTSP feeds, and you can see there's a little bit of a lag in there. The performance at the minute of my Jetson Nano is probably subpar, if I'm being honest, with when I first did this. But you can at least start to see that it's actually doing something. It's putting these colored boxes around. It's starting to recognize stuff on my screen. So, I mean, I can actually flick over to this application. It's a little windowed application running on the Jetson Nano. You can see that I can start to move it around. A part of the application means I can click on either of those images and get a bigger view. And now I can start to see the tags that are actually assigned. It's detected 2 cars there. I can click on me. It's not detecting anything at the minute. Oh, briefly, it just detected me as a person. Laptop, if I hold this cup up, maybe it will. Who knows? Like I say, there's a little bit of a lag in there. It's running a little bit slow, but I just held a few cups up there and just to see if it'll actually detect those in a second. Yeah, it's actually running quite a little bit slower. Believe it or not, this was running really fast before I joined the call, but it's usually the way, isn't it?
I'm hoping you trained it to recognise carjackers and stuff like that.
You think? Thieves. You think that's yeah? Well, I should do really, shouldn't I?
How cool would that be?
That is really lagging. Actually, that is a lot of lag in there. There we go. I held those cups up. Well, you can see. There we go. It's recognised the cup. That's the point. And occasionally it's recognizing my chair behind me. But fundamentally, I mean, that's where we're getting to. How did we put all of this together? How did we actually get this application to start putting these multicolored boxes around the screen? And furthermore, if we look at the log file of the DeepStream SDK container that's running on that IoT Edge device, we can see this whole plethora of messages just streaming up the screen, which, you know, obviously is far too quick human readable, but every time one of those boxes is drawn around the screen, if I break out of that now and just take a quick look at one of those messages, you can see that we're actually picking up, some JSON format messages that, give us a little bit of information, things like we've got a timestamp on there and it's, it's out by an hour. It's UTC, I think the time zone is not +1, but it's picking up that I got this sensor ID called Studio, which is the camera that's just off to the side of me here. And we got another message there, which is picking up the street camera, which is great. But then it's also sending these objects through, like an array of objects. So every time there's an inference and a detection done on that screen, it puts up that colored box around it and, assigns that object to it. And these numbers are actually the coordinates of that box that it draws around the image that it's detected there on the screen. So, I mean, fundamentally, we're getting all of that information streamed up pretty quickly from when, if I flick back over now, it's still running there on my Jetson Nano. So every time those boxes, I'm getting those messages sent. So you think, okay, well, that's great. Well, I actually haven't had to do much other than install a module on my Jetson Nano device and put something called a deep stream analytics module on there and configure it. And that's pretty much what I've had to do. So we can take another look at how we've configured these modules together. So remember, we've got 4 custom modules that are currently sat on that Jetson Nano doing something. At the minute, what I'm going to do quickly, bear with, I'm just going to quickly stop them and fire up the other 2 modules just because I don't want it to go offline. And earlier on, it was working fine. It wasn't going offline. So it might be all right, but I'm not going to take a risk. So all I'm going to do is I'm just going to stop the 2 modules that I just started, and I'm going to fire up the other 2 modules for the rest of this talk now. So you've seen that working. You've seen those boxes being drawn around the images as it goes. So what you've got to think about now is, right, okay, 2 things really. How do we deploy the modules onto the Edge device? Now, you could see earlier on, we could browse over to our Iot Edge device, and I could actually just click straight in here. I could click on something like set modules. If my internet is going to be nice to me, we could, sorry, not set modules. John Jetson modules. Yeah, wherever it's gone now. Deployments configurations. Tell you what, I'm going to just jump straight into showing you through the manifest, which is here. So we can you can actually go through a marketplace and install them via the Iot Hub itself and actually push them down to your Iot Edge devices, or you can browse through and use what's known as a manifest. Now, if you use VS Code, you can actually start one of these, like put the scaffolding up for one of these manifests and start off with a nice clean file, if you like, with just the Agent Edge and the Hub modules, those system modules installed. But in my case, I've got another 4 custom modules that I've had to kind of push down to that device. And, if you're not familiar with this syntax, this JSON syntax, then, I mean, I'm not overly familiar with it. I know enough to kind of string it together, but fundamentally we've got our system modules and then we move into the custom modules. And really we're just setting some parameters. So it's a Docker file effectively that we're using, where we're picking the container image that we actually want to use for this particular application. Now, in this case, our DeepStream SDK sample application is being pulled from the NVidia container registry, and it's this version 5.0-IoT. That's the version of the container. We set the entry point, which is called test app 5. I don't know if you saw in the screen earlier, you could see test app 5, but that's just what is running. And I'm passing it this configuration file, which really is the nuts and bolts. That's the brains behind how do we get that multiplexed image to do what we need it to do. We'll come back to this configuration file in a second, but I just wanted to show you the anatomy of one of these manifest files. We can set lots of other things. I'm not going to go into that in too much detail at the moment. It's just, how when you import them, I mean, you can literally right-click import new module, and it'll set the scaffolding up for you, depending on which module you select from either a marketplace, or you can make your own custom modules. But then I've got these other few custom modules. So the camera tagging module, I've got the Azure Blob Storage on Iot Edge, and I've got the Deep Stream Analytics. So there's 4 modules on there at the moment. We put them into the manifest, we right click, we can deploy, and we can push all of those down, and automatically the Edge agent will pull those images down and set them up for us on our Iot Edge device. The next thing we need to worry about once we've done that is actually the messaging, how do we want to route our messages between those modules? And we'll touch on that a little bit in a little while. But if we scroll back up to this DeepStream SDK module, like I say, one of the things that we're actually passing to it, the entry point for the actual app to run is this thing, DeepStream Test App 5, but we're passing this DS config Yolo v3 Tiny. And again, we'll get into a little bit why it's called Yolo v3 Tiny in a second. But again, these are sample configuration files that we can actually use to start configuring. So start configuring how we want that application to run. So how do we feed in those raw RTSP camera feeds? How do we present the application back with, a multi-tiled display? It's within this. So we've got these things called groups. So it's a group with a key value pair for a parameter. And what we've got is a whole bunch of these groups, which, to be honest with you, some of them are fairly obvious. Some of them you're going to need to do a little bit of reading and understanding as to why you might want to set something one way or another. But the important things here are the tile display. If you remember, I had one video over another. So that was set here, 2 rows, 1 column. If you had 4 cameras, you might set 2 rows, 2 columns. So you can display 4 camera feeds. And I think the 2 gig NVidia Jetson Nano would cater for up to 4 camera feeds. But arguably mine's feeling a bit poorly at the moment. But the heavier the device that you're using, the more camera feeds, for argument's sake. You can configure the width, the height. These are just standard things that you can pump in using this text file to actually display this on the other side. The next thing we move down to, and again, I'm not going to go into all of these in great detail, just to give you a bit of a flavor, but we've got this source 0 group. And in here, we're defining that we've got a type of 2, which is a URI. Okay, so it's a camera feed. You can see we can use, actually, there's a few more types. I think you can use type 5 and 6, which is like video feed, actual video files. But we can use the V4L2 camera, which you might have, hooked up to your device directly onto the board, or you could use an RTSP. But in my case, I'm using RTSP camera feed, but via the URI method. So this URI is actually the camera feed of the outside camera. Yeah. So hopefully you're following that I'm just literally using that URI, which, yes, you can see my username and password, which I have not changed from default. Great. The Chinese have got all my data anyway. So what does that matter? You can set things like, you can see a lot of these in my case are kind of commented out for the time being. And like I say, this is a sample file that you get. So they're kind of in there. So you can kind of see the things that you can do. But literally source 0, all I'm doing is I'm enabling it. Yes, it's a URI. There's my URI. And it's a reconnect every 60 seconds if it drops for whatever reason. It's really that simple. So I got a source 0, I got a source 1 because I got 2 camera feeds. You could copy and paste and create source 2, source 3, and so on and so forth. But fundamentally, this config file is made up of, like I say, the series of groups that you would go and set these key value pairs to make that application do what you need it to do. Remember, do you want tracking? Do you want a primary inference? Do you want a secondary inference? All of those kinds of things. And, even down to doing things like the on-screen display. Do you want to enable it? Do you want to put a clock on it? Do you want, you've got some common functionality in there that you can kind of dip into. Now, there is part of the DeepStream reference guide. There is a whole series of explanations as to what. So there's all of our groups that we just talked through. So things like the OSD group, the sync group, the source group. We can use this page to kind of browse down, right, when would I need to enable this tile display? It gives us a little bit of information and further reading to do. So we can kind of start to understand at a deeper level. But I've really kept it, not far from what was sent through and what Paul talked through in his original talks back last year. So but you can see that we can kind of start to tweak and change some of these parameters if we need to. So my advice is to use that reference application guide to kind of start playing about with some of these key value pairs to manipulate and change that application behavior. But fundamentally, we've got that application running now. So I think if we quickly just flick on to the next stage, which, I'm going to talk a little bit now about the custom vision AI versus a pre-trained model. So you saw that I had that thing called a Yolo v3 Tiny. We'll get to that now, but part of this now is, right, we've just looked at how that application is set up and running and how we actually configure it to run, using, for example, that configuration file to tweak our behavior of the application. How do we actually get a model? How do we train a model? What is a model? How do we what options have we got, I guess? So, I mean, the first option that I'm going to quickly talk you through is the custom vision AI model. We'll dig into that a little bit because there's a web page that we can go onto and I can show you a little bit about that. So we can train our own model to recognize objects of our choosing, in my case, people and cars, or we can use a pre-trained model. Now, pre-trained models come in a few different flavors, but I mean, if we look at NVIDIA, they've got a whole bunch of pre-trained models, and they've been trained to a really high standard with thousands, if not potentially millions of images to get the the inference and the actual percentage ratio of hit to correct images, really high. Or we can use something that's a bit more general purpose. Maybe it's a baseline model that we might want to use and maybe adapt and grow with as we get a bit more familiar with what we're actually trying to do. So for my purposes, it was like, well, I just want a model that's going to recognize something, to a point. But I did try looking at the custom vision AI. So we'll come back to that in a second. But if I jump back over to the desktop briefly, if we look at custom vision AI for a start, so custom vision, this is a web page that's available from Microsoft. You can sign in, log in, and start looking at getting your own custom vision AI model up and running, which is effectively what I've done. Now, fundamentally, it's a case of uploading as many pictures as you can and manually going into each picture and starting to tag those pictures. So again, I'm not going to dwell on this too much, but for example, I've got a whole bunch of untagged pictures in here that I've uploaded from other demos and things like that. And these are pictures taken from a little while back. But if I were to pick one, they're untagged. I could select that image. I could kind of hover. So part of custom vision AI, you can hover over kind of differences in the image and it will automatically put these bounding boxes on for you. But you could, in fact, just click on that and say, yeah, that is a car. I'm happy with that. Yeah, that is a car. But equally, if you want it to detect something that's not automatically, you can actually draw your own bounding boxes. So I mean, I don't know if you'll be able to tell, there is a drain cover there. It's very dim, but I could highlight that and I could call that a drain. But the point is, I'm manually now going through each image and tagging that image. And just to be aware that it takes at least 15 tags from 15 images to start to train a basic model. And you can start to see now that if I'm tagging this, it's great. That image has been taken at during the daytime. It's relatively sunny, but you've got to think of environmental factors when it comes to training models. If in the level of precision that you get from actually running that model and getting that that hit correct, there's lots of things that come into play. Now, hopefully you'll see that actually, if I were to go through that, I could say yes, okay, I've trained that. Move on to my next one. Do the same car, well, that's a car. Hopefully you get the idea that this is great if you've got something very custom that you want to do, like detect something that a pre-trained model isn't going to know about, but it's very time consuming. It will take a bit of time. So as you work through that and you build that up, you can use custom vision AI to tag all the images that you need to tag. And then you can move into training that image. You can train it quick or advanced training, and you could even do a quick test. So, obviously I've trained this a little while back now. It's not the most accurate of things in the world, but for example, if I were to browse to my desktop and find one of those images, and again, these are just images. I've got probably about 1,000 of these images in there that I just left run. So if I were to pick any one of these images that hasn't been trained, straight away, you're starting to see that there's a bit of a match there. So it's saying, right, that's a van, 91% chance that's a car, 73% chance. So you can see that I'm getting pretty decent results. And this is a model that I've trained over time. But, at the end of the day, I've not taken into account those environmental factors. So they are all things that you need to worry about. What does it look like at nighttime? What about if it were raining? I've got my camera sat behind a pane of glass. What if it rains and there's droplets down the glass? What if there's glare off the glass? Put it this way, my camera's not in an ideal position if I were doing this for anything other than learning purposes. But the point is still the same, whatever you're going to do, you've got to think about how the environment affects the images and how you're going to train that model. So the long and short of me showing you this custom vision AI is that it's great and it does what it needs to do, but it's very time consuming and very labor intensive. It'll take you quite a long time to build that up, which is great if that's what you need. However, back to the point of what I started to use, which was one of these pre-trained models. So in fact, the pre-trained model that I went ahead and used for this particular example is the Yolo v3 tiny model. So you only look once. It's a model. It's a general purpose model that's being defined and trained, and the tiny version of the model will detect, I believe, up to about 80 different objects. And one of the comedy things that I saw that it would detect is a giraffe. So we'll have a check in a second to see if I've had any giraffes walk past the window. But fundamentally, it's really something that you can download and install and get up and running and deployed onto the Nano. Again, you've got all the sample files there for you to literally, download these thing called weights and tags and put them on your Jetson Nano, and you're up and running within a matter of however long it takes for you to kind of save that file over to your device. But fundamentally for me, that was cool because now I could just, literally jump on and start playing with the object detection and have it detect lots of different things. So that's the route that I took. And again, for the interest of time, I'm going to shift along straight away to the telemetry side. So once we've got our model trained and it's running, and I've shown you there, we've got those two images, the camera feeds that were being taken into that multiplexed image. The inference was being done through that pipeline using that Yolo v3 model to then draw those bounding boxes, recognize, the percentage, the chance that it's a car or it's a person or one of those other 80 things that the Yolo v3 model was detecting. You saw that it detected that I had a cup. It was seeing the chair. It was seeing a TV monitor off to the side. 80 different things. Right, I thought that will do me. That's perfect. I can start to get some data. So every time one of those boxes is drawn, the application sends one of those AMQP messages, those IoT messages, and it sends it on somewhere. And where that somewhere is the stream analytics job. So, right, what is a stream analytics job? So fundamentally, it's using real-time analytics, really for that complex event processing type work that you might have to do. So it's really been designed to analyze and process really high volumes of fast streaming data from multiple sources, all simultaneously, doing it in real time. So things like patterns and relationships between data can be identified using kind of SQL syntax query language in order to kind of do something with it. What do you want to do with that stream of data? At the end of the day, we saw earlier on that, I had a huge number of messages streaming up my screen every time there was an object detected. Now, what do I want to do with that? Remember, that's running on my edge device. Fundamentally, that's running local to the actual processing of that data. Do I really need to stream all of those messages up to the cloud? Would I want to stream all of those messages up to the cloud? So fundamentally, that's what it does. So it takes the device information, streams it up to IoT Hub, which the IoT Hub in that case, on this instance, is the local IoT Hub, that system module on the IoT Edge device itself. It then routes the message through a stream analytics job that does some transform potentially, so that transform of the data into something that's more meaningful or more adaptable to what you need for your application, and then fundamentally send it on somewhere else. So in our case, it's sending up to the IoT Hub in Azure, but that then sends it onto something like a dynamic dashboarding or data warehouse or storage account. Remember, we had that plethora of things that we could have sent it to. So I think for the purposes of the stream analytics, like I say, once we understand that we're going to do some data transform on those messages coming in to the stream analytics job, you've got to think, how does that actually work? So like I said earlier, it is a SQL syntax language. We'll take a quick look at that in a second. But you've got this concept of basically window functions. In this case, we're using the function called tumbling window, which hopefully by this diagram, you can see that it takes the previous 10 seconds worth of messages, then it runs a SQL query over those messages that it may be transform, spit out one message. 10 seconds later, take the previous 10 seconds worth of messages, do some transform, spit it out, and so on and so forth. So that 10-second tumbling window. So all of a sudden, we've got the ability to start doing some transform locally on the edge, which is actually what we're doing. So if I fire quickly back over, flip my windows around here. and go on to our Stream Analytics job. So again, Stream Analytics jobs are created in the Azure portal. In our case, I've got two. So the one that we're interested in is a Stream Analytics job that runs on the Edge device. You've got two options. You can either run them on the Edge device, which is one of those custom modules, that Deep Stream Analytics module we've got running, or you can run them as cloud jobs. So I've got two. I've got one that's running as an Edge device, which is the one we're going to look at now. And we've got this set up. And like I say, it's got this input and these two outputs. And we've got this SQL query that's actually running and doing that transform. So basically, every time a message comes from that application, that Deep Stream SDK application, that Test App 5, all of those streaming messages will be sent from that Deep Stream SDK module, that container, and it will be sent to this Deep Stream input. And you remember when we looked at this manifest earlier, this is how we configure that routing, because we've got to tell the manifest, how do we route those messages? And if I quickly scroll down to the area of messaging, we can see that we've got these routes defined to say anything from NVIDIA Deep Stream SDK to my Deep Stream Analytics. This is how we're going to send it. So anything from this module, any output, we haven't defined an output, hence the star, we're going to send it to this module to an input called Deep Stream input. So that's our routing. So in other words, anything from the Deep Stream Test 5 application is going to be sent to the Deep Stream Analytics module, to this input called Deep Stream input. So if we flick back over here, we can see that we've got this Deep Stream input here already. We've defined it, we've configured it. So any message that comes in from here is going to be, is going to be passed with this SQL query, which, like I say, is fundamentally using this tumbling window function. So that every 15 seconds, this function will run and it will send the message into this aggregated detection. But equally, we've got two outputs here. So we've got the ability to send one version of the function to this output called aggregated detections. And we could then add to our SQL query, which is exactly what we've done. So from aggregate detections, we're now going to do some other transform and send it to another output called summarize detections. So all of a sudden now, we've got the ability to take all of that stream of data from that application, do some transform, and now split off two different versions of that data if we want to, which is effectively what we're doing here. So if I were to quickly flick back to the NVIDIA, I'm going to start it back up quickly again. It shouldn't take too long. Bear with. So I'll leave that starting back up in the background quickly. So that's just my Deep Stream Analytics job on my NVIDIA Deep Stream SDK that's going to start back up. So that's started back up now. So if I quickly look at the logs again, you can see, so all of this information now, so all of that sort of, guessing probably a good, what's happening in the application as it happens through that config that I didn't mention earlier, every fourth frame of video, it's doing an inference, a detection over that fourth frame of video. And once it starts doing that detection, any objects that it detects, which is it can detect multiple objects in a single frame of video using that Yolo v3 model, every time it detects, it sends one of these messages. So you can see that it could be sending potentially, with 30 frames per second, and we're detecting 3 or 4 objects in every 4 frames. It could be sending many messages per second. So this is just starting up. So in a second, we should see those messages fly up the screen there again. But fundamentally, remember, they're all being sent to this Stream Analytics query that's running on our Edge device itself. So, for example, now, if we wanted to check what was going on there, we could browse back over to our VS Code. And we got the ability using the extensions, the IoT Hub extensions that we can use in VS Code to kind of see our Jetson Nano, my John Jetson, which is configured in my IoT Hub there in my Azure subscription. And I could actually start to monitor the output. So actually, when I monitor the output of this John Jetson, this is actually monitoring what messaging is actually being received into the IoT Hub. So if I were to monitor that now, or at least start it. So you hopefully this will start to, make a little bit of sense in terms of that's running now in real time. We've got all of these messages, like I say, several objects every 4th frame, 4 frame, 30 frames per second. You're looking at inferences of, 5-6 times per second with multiple objects in each of those, there's lots of messages. Yet, if I start to look at what's actually being received into the IoT Hub in the cloud, I'm getting a message sent. There we go. So 7:59:36 seconds, 7:39, 59 and 51 seconds. So what's that? Every 15 seconds. And so you can see now that it's actually that tumbling window function, this one here, that every 15 seconds, it's doing some transform and it's sending it to this output. This output then is being routed somewhere else. And so where do we need to go to find out where that's routed to? So we browse back over to the manifest and we see, right, so where is our message being sent from the Deep Stream Analytics module? So you can see there that we've got this rule called, or this route called, from Deep Stream Analytics to IoT Hub. And lo and behold, anything from Deep Stream Analytics summarize detections, send it to upstream. So $upstream is just another name for send it out to the associated IoT Hub that this device is connected to, which in our case is the hub that I'm currently monitoring down here. So hopefully you can start to see now that we can take potentially thousands of messages. We can use Stream Analytics to process those messages and aggregate the data, or summarize the data, which is what we're doing in this case, and send just that one message up to the cloud rather than sending that myriad of messages. So that is really a little bit around Stream Analytics. So to move on to the next part of what we're going to look at here, if I can find my window properly. That's great. So we've got all those messages flying up there now. So how do we actually start to make sense of some of that data? So the first thing we're going to quickly look at is time series insights. Again, this is really a feature that you can set up through your Azure portal, which we'll have a look at in a second. And we can start to really take a view of that data. So let's hook up time series insights onto our IoT Hub and see if we can do some quick data visualization using a pre-canned application called Time Series Insights to really do this ad hoc kind of traverse back through our data store and see what kind of data we're getting through and see if we can kind of glean some quick insights. So what I did is, because the data of detecting a person or a car is relatively bland, I actually hooked up I got this little MX chip device, this little dev kit that, I know Cliff loves temperature and humidity, but, there we go. There would be no IoT talk complete without some temperature and humidity. So I've just hooked up this device that, to be honest, is plugged in constantly. Whenever I feel like playing and having a little look at something, this is constantly running in my office, and I've got it hooked up to a Time Series Insights configuration. So that's what we're going to quickly take a look at. And there we go. In true Blue Peter style, there's one I prepared earlier. So that little device has now been configured, and we've hooked up a Time Series Insights session up to that particular IoT Hub. This is actually run through a different IoT Hub, but you can see that quickly at a glance, I've not really had to do too much configuration other than hook it up to my IoT Hub. I could click on my device, I could select my temperature and humidity, put them in lanes like this, and without, before you know it, in fact, if I delete those, you're presented with an empty screen. You can see how quickly we can kind of hook up. Let's have a look now. If I go I always pick the wrong one because it marks it a couple of times. If I go temperature and humidity there, add those in, and you can see how quickly it will actually get back to presenting some data that we can do, fairly quick ad hoc, looking over. Along the top here, we've got this little timeline of every time I've had this device on. You can see when I turn the computer off, it goes offline. But we can kind of zoom in to, a few days ago. Let's just quickly zoom into that area. We can zoom in back to the end of August when I had it on for a period of time. We can see, hopefully it makes sense. So you can see that when I'm working in this office, I can get up to about 35 degrees, which, is quite warm in here. And equally, humidity, can be around about the 50% mark. But all I'm trying to say is, from that device just sat running in my office, I can use Time Series Insights to really just quickly jump in and take some quick insights into what's going on with that data. So if we take a look at the object detection data, what does that look like? Well, that's why I thought I'd show the MX chip, because look, the data that I'm getting for my object detection isn't as exciting. There's not really a lot going on. How many people in the studio? Me, one. Okay, great. How many cars in the street? Well, one, maybe two, sometimes three. So basically, the data that it's getting back, and if I span to the time that we've been running and talking about it in this event. You can see, you get the idea. We're able to kind of quickly visualize that at one point there were 3 vehicles in the street that are detected. Another point there was 1, and you can kind of start to align it with the time. So, if you look at the bottom of the screen there, we're looking down here. So around about 6:45, there were 3 vehicles in the street, for example. So the point is they're quick insights that you can glean from the data from your application by using time series insights. So hopefully that makes a little bit of sense as to why you might want to use that. So it's just that timestamp data, really getting those quick insights. So to move back to the next section, the final section really is around, the same means. How do we take that data now and actually make it actually meaningful and rich? How do we interrogate all those messages that are being sent from our object detection, from our Jetson Nano? They're all being processed through that stream analytics job. They're being transformed, and a message every 15 seconds is now being sent out to the IoT Hub that we can use time series insights to use for quick ad hoc insights over that data if we need to. How do we take that into something like Power BI? Can we do something extra with that data and do, actually visualize that in any better way? So in true sense, I'm going to flick over to my Power BI. So again, with Microsoft, with any licensing or free licensing that you may or may not have, you can start to use Power BI to really start to visualize this data. Now, if you remember, we had 2 stream analytics jobs. So if I flick back over to my Azure portal, you'll see that I've also got this other job running. So you remember we had this deep stream analytics job, which was an edge job that was running, because we've got 2 different types, edge and cloud. That was running on our Jetson Nano. Now we're going to run one in the cloud. So we've got this other job called IoT Hub to Power BI, which is a cloud job. Now, if you set up a Power BI, to set these jobs up is really relatively straightforward. You can actually select, I want to stream it to a data set in a Power BI workspace. So as long as you've got a workspace that you want to send it to, you can literally create new stream analytics job. It's a cloud job. I want to send it to a data set in Power BI. And you can see it's a relatively straightforward query that we've got here. We've got 1 input, 1 output. We're going to select everything from our IoT Hub. We're going to put it into a table called Stream Analytics Cloud Outputs. And that's it. And we're going to timestamp it by the timestamp. So we're not doing any transform. We're literally taking all of those messages every 15 seconds and just sending them now straight to a Power BI data set. We could be sending those onto a storage account or a Cosmos DB or so on and so forth. There's so many different ways that we could be sending these messages. So I'm actually just sending them straight to a Power BI data set. And that Power BI data set is in my workspace here called Intelligent Video Analytics. And I've got a data set called Intelligent Video Analytics data set. So every single message, those 15-second messages through the IoT Hub, is just being sent directly to this data set. So brilliant. Now I've got a data set with all of that information in there, with all the objects, the timestamps, the camera that it's been coming from. Okay, I can start to actually create a little bit more visualization content on top of it. So the first thing that you can do is set up a Power BI report. So in this case, again, this is all available on Paul DiCarlo's GitHub repo. So if you haven't seen that, if you browse on over, I put a link earlier on, but if you browse on over to Toolbox, and that's Paul DiCarlo's GitHub, and search for that particular repo, you'll find all the instructions on how to do all of this yourself, and notwithstanding the Power BI dashboard as well. But fundamentally, we can now start to visualize pretty quickly. We can drop these components on and start to carve them up in real time with relatively little, effort, I think is probably fair to say. The only thing is, if anybody knows, how you change it to UTC +1, because it's not as easy as you might have thought in Power BI for whatever reason. I think it's the format of the timestamp that's coming through. It's, for whatever reason, found it really a struggle. So all of these times are an hour out. Okay, so just bear with. So, if we look now, we're kind of right up to date here. So 7 o'clock onwards, which, is an hour earlier. So it's 8 o'clock. we can start to see, actually, yes, we've got some really rich data here now. We've got these 2 sensor IDs, which relate to the cameras that I've got set up. So we can start to really drill down into them and get some visualization. So do you remember that the Yolo v3 actually detected up to 80 different objects? And within the time, so this is actually set now to actually just report on the data since I've been doing this talk. So apparently since I've been talking the last hour or so, we've detected a banana, a backpack, we bowl, a cup. Okay, I can understand that one. Hot dog. I don't remember seeing a hot dog myself. But, you know, you get the idea. The point is there's no giraffe in there, I like to say, you know. So you might be asking, okay, well, that sounds a bit strange. Right? How did we detect a mouse? When was that detected? Okay, that was detected. Apparently, there's still one around here somewhere. That's at 7 o'clock, which, you know, sort of 10 minutes ago. It still detected a mouse on the studio camera. So I'm not sure if it means the computer mouse or something ran behind me, but hey ho. But the point is, you can start to drill down. You might think, well, actually, you know, why is it detecting all these objects? Now, just cast your mind back to the model I selected and the reasons why I selected that model, that Yolo v3 model I selected, because look, I just wanted to get up and running pretty quickly with something that was a general purpose, relatively well trained. But the bottom line is it's going to make mistakes. It's not going to be high precision on everything that it sees. It's going to get things wrong. And this is proof of the pudding. You know, it's picked up a whole lot of stuff. Apparently there's a dining table. Yeah, okay. 2 o'clock, well, 3 o'clock earlier on, it detected a dining table. But you get the idea. The point is, if you train that model to high precision or use a really high precision model, you're going to get better results in your Power BI dashboard. But the general rule of thumb around people and cars, I kind of kept relatively, you know, decent in terms of detecting, and it does work pretty well. So the first thing we do is we can fire off a report like that. And then what we can do is we can start to fire off and save those reports. And we can actually start to, you know, sort of assign them onto, you know, various visualization dashboards. So you imagine you can take this a stage further now. I've got my report there, but actually I can use Power BI to start interrogating my data in you know, really, you know, straightforward English language. I say straightforward within reason. So count of car over time are in street. See? Okay, so it's given me something back, no idea. But the point is, you can start to use natural English language with Power BI and start to really drill into your data. So we could say max count of person in studio, if I can spell, in last 24 hours.
You can't spell studio.
Yeah, that would help, wouldn't it? Yeah, but look, you can see it. I mean, it's a good demo there, Pete, actually, because you got it wrong, and it'll actually pick it up and say, well, did you mean studio? It's still understood that. So in the last 24 hours, it's detected 291 detections of a person in the studio. Okay, so you can think, well, how can we start to use this kind of information now? And hopefully it doesn't take too much to realize that actually we could start pinning these kind of tiles upon our Power BI dashboard. Now, it's not always about the fact that, yeah, it was nice seeing that pretty image and all those boxes, you know, streaming up now on that Jetson Nano, but that Jetson Nano can sit wherever it's sitting, constantly streaming this. And this is actually the insights that we get for the application, you know, off the back of it. You know, things like the last detection of a car in the last 24 hours. Apparently, that was 7:13. Remember, I'm an hour out. So that was literally just now. There was a car in the street. So you imagine the power of maybe pointing a camera at your car and just your car on your drive. You imagine if that car went missing, you know, it wasn't in shot and it was no longer being detected. Now you could also think, well, I could hook that up to some kind of an alert. So straight away, your security system can now detect whether your car is sat on your drive. And if it's not sat there, you could have it do something, maybe, you know, automatically ring the police or whatever. So you can start to see that these kind of applications are really about the creativity of your imagination at this stage. So, you know, things like last detection of a person last 24 hours. So apparently in the studio, well, lo and behold, it was now, you know, that'd be me. And in the street, apparently somebody walked past sort of 9 minutes ago. And this is real-time data. You can see it was last refreshed now. You can see the screen flicking every now and again because I've got it to refresh relatively quickly. But the bottom line is we can start to ask questions about our data in, relatively straightforward language and pin those visualizations to a dashboard that we could use and display. We could export this, send it to a website, or have it as a web app, anything like that. So all of a sudden, you can start to see how that end-to-end device, from going from that Jetson Nano, from implementing, obviously all the stuff that you need to implement in terms of the DeepStream SDK, the configuration file, your video feeds, your object detection and training your own model, or using a general purpose model. Hopefully you can start to see how you can glue some of these components together to then stream those messages out to a stream analytics job, to do some transformation on all that data that's coming out of the Jetson Nano, and send that on to the IoT Hub. And then once it's sat there in the IoT Hub, push it on somewhere else. In our case, we had a look at time series insights, so that quick ad hoc overview of that kind of timestamp data. You can get those quick insights, or you can take it onto a bit more of a powerful data visualization platform like Power BI, where you can leverage all of the benefits of these platforms, like natural language kind of questioning about the data, and really start to pull together some of these insights in graphical form, pie charts, bar charts, with relative ease. So on that note, I think I'm going to pause there. Happy to answer any questions. I really do appreciate, there's a lot of information we've just been through, and it takes, quite some thought, and I have to jump around. And there is some stuff that I've missed out there, but happy to have a chat with anybody if there's anything anybody else wants to know further. But I think we'll leave it there, Pete. I think we're reasonably well for time.
That was absolutely. This is the second time I've seen this talk, Johnny, and this is better than the first time even. And the first time was awesome. That literally is the detail that you go into there, but you still manage to skip through all those different topics is awesome. That flick back to that Power BI dashboard.
Yeah.
Because that all on its own, and if you've never done any Power BI, it's not straightforward. It's okay, but it takes a bit of learning to actually get the queries to work properly, and then to use that to surface that as, that part you've got in there in the middle.
This one here.
Just back down.
Yeah.
Is that live data that you've got there?
That is live data. That data. So if I go back to my report, that is live data. So it's it's a count of the number of detections, and it's just organized by what object it detected, and it's just splitting it out into a line chart, an overlaid line chart. But the point is, with Power BI, we could edit this pretty quickly. You could see the visualizations. We could literally drag, another bar chart onto the page potentially, and start to drag our parameters. What do we want for the axes? What legend are we going to put in there? What values do we want to use? And build it up like that. But it's such a powerful platform that all of a sudden, all that data you can kind of quickly visualize. Like I say, you're right. It's not with zero effort. You've got to tweak, and like I say, one of the niggles I had is, for the life of me, I couldn't figure out how to change into UTC +1.
I'm not sure you can. I did a bit of looking around, and I think it's basically what you have to have is a custom column and do some maths. But I think for the most part, you can't change that from UTC. The desktop version you can, but the web version you can't for some reason. But mind you, the thing I was looking at was from 2017, but it kind of does make some sense, but not today. It doesn't. So,
Johnny, can you not? Johnny, can you not add it in the time series insights where you do the by timestamp? Can you not add one there?
Yeah. Well, the thing is with time series insights is that it's kind of like a pre-built application essentially. So, when we look at, as it happens, the time series insights gets the time right. I'm just trying to find the, bizarrely. If we flick back over to the time series insights and look at the timings, it's actually picking it up correctly. Yeah, so you can see 8:03. Okay, maybe I need to auto refresh is off. So if I just auto refresh that and make sure I'm at the end of my, so you can see that time series insights actually converts it and gets it right. But you're right though. I mean, when I looked into it, there were ways to add a custom column and do the maths, but even that, the logic in it was a little bit fiddly, and I couldn't get it working properly. So I thought, well, there we go. It's just one of those things that, hey ho.
I know Cliff just talked about this as well. I'm sure I've managed to figure it out, but I don't know how, and because it was a while back. What subscription are you using to be able to get access to this? Because Cliff's right, you do need a certain subscription, but I think I got an E3 subscription which gave me Power BI.
Yeah, no, you're right. Licensing on Power BI, absolutely. I mean, as it happens, I got an E5 subscription, so
Right.
I'm probably quite graced in that in the sense that I got access to the full McConkey licensing from 365. But yeah, the exact requirements I'm not too sure from a licensing point of view off the top of my head. But yeah, it's going to be no doubt you can buy individual sort of licenses if you needed to, but to be honest, the best bet is just to hope that if you've got a license with the business you're working for, that they've kind of just left that turned on for you. Lots of businesses don't, unfortunately, but go and have a chat with your IT friend.
Yeah, that BA is going to offer something like that, Cliff?
Yeah, right.
But it is cool.
We barely get email.
Make you use Gmail, is that?
That's when it comes to doing the dashboards, they are pretty cool. I mean, I wasn't going to go into it there, but you can start to really dig into the data now. Objects and timestamps is really all we're capturing in this data set. So there's not really a lot you can ask it other than how many detections in the last hour. Like if I can get back to my workspace.
Well, there's a lot you can do with that. I mean, the fact that you're getting your time series data and your object detection, you can then start, the piece of research that I'm involved in is doing anomaly detection. So if you're detecting certain events at certain periods of time over a certain sequence, like I see a car at 9 a.m. every morning, we can start looking for things that have a standard deviation, and it's like, oh, I'm now seeing a car at 1 o'clock, and then alert on it, right? So actually having time series data through object detection, reducing something to a data stream means you've now got access to other things that you can do in terms of response. So moving from observability to actually doing something with that.
Like how long a milkman dwells outside your house, or the fact that neighbours late for work, that sort of stuff. Yeah.
We don't need to talk about that, Cliff.
Sorry there, Cliff. Sorry.
Yeah, fair. Yeah, it is a good-looking milkman. Johnny, do you know how you would then, because what you've done is you've taken an IoT Edge solution and then you're processing that through Stream Analytics, and then through Stream Analytics out to TSI, then from TSI to Power BI. You've got to Power BI, which feels like the end of the road as far as visualization is concerned. But as Charles has said, it's not the end of the road, actually, because then being able to alert on that sort of detail and feed that system back, it feels like it wants to go back to IoT Hub and then out from there to trigger workflows and things like that. Is that something you've looked at? Or?
Well, yeah. Well, remember that Stream Analytics job that we created, the cloud job, we were using to split two separate pieces or two separate inferences. Inferences, what am I using the words for? Getting confused myself. So we were using this SQL expression to fundamentally take the input data and split it out to two outputs. So this is the publisher subscriber model. We could have TSI assigned to the summarized detections. We could have Power BI on the aggregate detections. We could set a third output to send that off to a Cosmos DB. We could send it off to anything then that we could hook in maybe as your monitoring and maybe alerts, or we could use whatever. We could go and create an Azure function to go and do some kind of an alerting, send an email, or, when this particular thing happens.
That's where my brain goes, is having an Azure function in there somewhere where you can write some custom code, some custom logic that could take multiple inputs and then make some inferences of its own. But there's obviously a sharing of resource there where you'd want to put the responsibility for inference detection. Like you've said, we had a car at 9 a.m. every day, and now it's not at 9, it's at 1. You probably wouldn't want that in an Azure function. That would want to be an anomaly detection somewhere else, and then the output of that into an Azure function that then triggers a workflow somewhere.
You could have you leave the data flow here intact, but where you're writing the data, you have something else watching the data as well. do the maths, because if it detects an anomaly, what you want it to do is track back. Like, oh, I've seen an anomaly. Am I seeing this elsewhere?
Mm-hmm.
And then sort of backtrack that window and see, oh yeah, I've seen it before. There he is. I guess what I'm saying is the fact that you've got this one data stream and we're storing it somewhere. We're storing the raw data, and we've got one SQL function against that data stream. If we add just a little bit to it to say let's store that somewhere, and then have something else that's observing that same stored data, and then you can ask different questions of it in non-real time or near real time, and it's separate, right? You get separate areas of concern, and you start doing really clever stuff.
Well, definitely. I mean, remember though that I can't remember how many days it is, but is it something like 30 days or 90 days TSI holds by default? So you can go back 30 days, and it's got this hot storage area and this cool storage area. But this is a particular thing that, okay, it's taking the input, but the data doesn't stay in time series insights for anything longer than the set 30-day period. Yeah. So, you would really, so IoT Hub, you can set the timers for how long the data stays in IoT Hub before it's picked up by something. But yeah, you really want to be, streaming it out to a storage account or a Cosmos DB or something like that, then you would, like you say, Charles, just go and do something with it.
It's all pretty awesome, isn't it?
It is. It feels like we're on the cusp of all of this, though, because exactly what you were just saying there, Charles, that feedback mechanism to be then take that data and feed it back and then use it cognitively against existing data, like John's just said there. That's where we aren't at the moment, at least not with this low or no code version of things that Microsoft are pushing. Certainly Power BI, you've just seen there, you can just drag and drop things to a certain degree. The NLP, the natural language processing of the queries that you've got on the screen just there is great. And things like the Percept are all great for low code and no code, but actually making it usable for real world purposes, there's nothing really there unless it's, reasonably straightforward. I know Cliff's had an excellent blog post on recognizing airplane parts for when he's building his Sting airplane, which is a great use of exactly what this thing was designed for. But if you want to do something a little bit more complicated, like Alan's put in the chat there, the cat was detected in the kitchen. What time is it? It's feeding time. Serve out the fresh food. There isn't a workflow that's no code or low code for that. You'd have to write it.
I think that's the secret sauce, right? That's where we're hooking out to Azure functions, like John.
I think the idea is. I think the idea is, though, that's where developers come in to write those code blocks that then someone in the office within the business can then, it appears in their account, and then they can use that as an extra block they can drag onto the screen onto their Power BI.
Logic apps.
Like logic apps and stuff like that, developed by a developer that knows how to code, but it then becomes a kind of no code option for, your person that works in finance or in people or, wherever else in the business that they work, and they pull that into their Power BI to make it work. So there's still jobs for us. Basically, they're not going to go completely low code, no code, and we'll be out of a job. So
unless you're a pilot, Cliff.
Well, there is that, because you need people to get on planes. Well,
we just sent four amateur astronomers into space with absolutely no pilot or experience other than 6 months of training.
One of them is a pilot.
Well, they had 6 months of training, but they're all amateur astronomers.
Yeah, one of them's a pilot. One of them's sort of got thousands of hours flying like jets and stuff like that. Like
I'd be happy if you came up into space with me. I wouldn't be happy if you weren't there and it was just me.
I ain't going into space without Cliff.
That's fair. I'll give you that.
Right. Okay.
You're almost there all the time, Cliff. I mean, let's be honest.
43,000 feet, close enough.
Yeah. Anyway, I mean, Alan and David and Andy, did you have any? I mean, I kind of took over the conversation there. It was really bad hosting. Did you have any questions? Are you still alive? Oh, David is.
Still alive. Only questions I've got. I've got an NVIDIA myself, and I sort of started playing with it in the box. It's the usual stuff of screen drivers for the television. It doesn't work very well. It works fine with the computer monitors, but I've got like an old TV screen. It just doesn't drive it very well.
What quality of the image, or actually getting the output?
It's really pants, and it's really bizarre because the Raspberry Pi just plugs in and works straight away.
I wonder, is there a setting for the resolution that it's not auto setting for your telly for some reason?
Okay.
That image there is straight off the HDMI off the card. That is an HDMI image there, so it's pretty crisp when you look at it. Yeah, I don't know whether there is a.
Yeah, this is it. It's HDMI input, and it's fine on a sort of a monitor, but the sort of telly just doesn't do it. Whereas the Raspberry Pi is no problem; it just plugs in straight off the.
What does the telly say the signal is?
Eh?
What does the telly say the signal is when you've got it connected via HDMI?
Oh, God, no,
if you go to info or whatever on your telly, normally it'll tell you what the signal is. It's maybe driving something horrendous like a 480p or something.
Yeah, that's what it sounds like it's doing. Or is your telly an old BBC monitor? Is that what it is?
It's not that old.
It's only Trinitron.
It's flat screen. It's not got.
I was going to ask, was it flat?
Yeah, well, it's got an HDMI input, so I mean that puts it in a certain. I mean, it sounds like it's defaulting to the wrong resolution. That's what it sounds like. But I mean,
basically what it's doing, it's just it looks like a screen driver. There's loads of settings on the telly to get into the right one.
What are you running on it? The same Linux base, yeah. Because you should be able to just go into the settings and go into the graphics settings and make sure your whatever it is, overlay driver, etc., is all disabled or enabled. I
haven't looked at it for a month or two. I think I've sort of gone through the videos, put it in the box, got it working, and then sort of other things have come up. So it's
a little bit like mine.
Mine is like many other things. It's just headless. I just log into it remotely.
Yeah. Yeah, I can do that. I can do sort of SSH into it. Yeah, that's as far as I got. Because the other one, I've done sort of the AI detection with the Raspberry Pi and put together some programs for that. And then just a single camera running on me. It says I'm a whale, so I got upset with that one.
Well, actually, I used the same tiny model on. I was doing. It's funny enough that I don't know if you remember. I was doing that cat detector.
Oh yeah, that's right. Yeah.
I was playing about that. I used the same model, and it did actually detect it. Actually, no, it was a slightly different model, but from Yolo, I detected it as a Siamese cat.
New car.
It was a dog.
I still got it. It wasn't a Siamese cat, but it just had the same color markings, which I thought was quite curious. You know, it was a similar color, but it wasn't actually a Siamese cat. But I'm not going to nitpick at a model.
What about you, Andy? Did you have any questions? Andy's head's exploded with all the information you've imparted there, Johnny. That's what the problem is.
Well, mine nearly exploded halfway through that.
That was good.
It's funny because
No, I mean, the questions I have are mainly for myself, because you see these things, you go, okay, and then what, where, how?
Oh.
The utilization, shall we say, of it's like the bird detecting stuff and everything. It's like, it's what's the best way of saying it?
Demoware.
It's a route to lots of interesting experiments, but I can't think of a product that will move the needle in the world from it, apart from some really insidious time and motion study things for businesses and factories and various other delivery companies to use for logistics. It's like, oh, Fred, your loading time is 15 minutes slower on average than everyone else's. Yeah. But of course, that could be useful in some ways of making sure someone is properly trained and stuff. But the more interesting thing for society is someone driving a car through the local park. You know, there should not be a car there. Let's close the gates. They can't get out. We've got them.
Well, the kind of things I'm looking at, which are a bit more industrial, is having a camera pointing at a machine and doing two things. One is assessing the product that the machine is producing, and trying to do video detection of things that have got a standard deviation. So it's not produced it correctly, so it doesn't look right. That kind of thing. So you've got that high. When something's churning out, I don't know, let's say baked beans or whatever, the tin doesn't look right for whatever reason, or the label's wrong or whatever.
They have those. They have those on the production lines. It's incredible how fast some of them can be scanning as well.
Yeah, well, we're trying to do that in the kind of IoT context, and the second thing is the machine itself. So if the machine fails, you're kind of stuffed, right? But the same thing, if you're over maintaining it, you're also stopping production as well. But the other thing that I've got to be careful what I say here, but the other thing that kind of looking at is are you running a building too hot or too cold compared to the ambient temperature and humidity outside, right? So whereas John's been analyzing the temperature and humidity, right, you can also measure what that is inside and outside as well, and then compare are they wildly off, and are you spending too much money on energy, right? And this is where the time series data comes in really well, because if you've got like loads of buildings, say you're a council running all these council buildings, or a hospital trust or something like that, or a company that has loads of buildings everywhere, that those numbers can start adding up. It multiplies by the number of buildings you're tracking.
You could do that there with what Johnny's got. That image there.
That's exactly
We've been watching it for 10 minutes now, and we haven't seen a person. So what's all the street lights on for?
Yeah, that's exactly the kind of
turn
thing.
them off, save electricity, that sort of thing. Going back to the watching machines and that, we used to, when I worked in the car industry, we used to have a machine that drilled the oil holes in the bottom of the block, and they were 0.8 millimeter drill bits, and they'd snap 3 or 4 times a day. So we used to have to stop the machine every hour to check if the drills were still in place. There was 8 of them, and change them as needed. But if it snaps like a minute after you changed it, it'd be an hour later, then you'd have to recall that hour's worth of production to then get them all machined again, and it'd take you like another day to catch up with the production rate. But something like this would have been able to spot that. I mean, admittedly, this was like 20, 25 years ago, but it would have been easy for it to spot it and resolve the issue and tell you, right, that you could check it every single pass of a block and say, well, actually, that drill number 4 is now broken. You need to come and get it. But yeah, it's powerful, but it's I often find it's us with a developer mindset. We can't see the problem, so we need someone to say, I've got this problem, and then our developer tools and what we know and love can then go and resolve the issue. I find often we're not very good at coming up with problems. We're just very good at coming up with solutions.
Yeah, I agree with that. It's that problem statement. There's probably people walking around right now with big problems, but they're not telling them to anyone. And it's like, but that could be solved.
So some of them shouldn't tell us though.
Yeah, let's put that into
Well, look, it's 25 to 9, and I know a lot of you want to get back to your families and stuff like that. Charles, you and I need to still have our offline talk because obviously exactly what you just talked about there overlaps with exactly what I've been working on with BT as well. So we need to have a chat, and maybe even Johnny Chips can get involved because we've all got the same NDA signed. So.
Well, if you look me up on Bright Talk last week, I did a talk on similar issues last week.
Okay, that's cool.
Yeah,
but moving on, obviously, don't forget all the other upcoming meetings. We've got my talk on Monday, and we've got another Knots IoT on the 14th of October, and 27th we got Knots .NET Knots, and 28th is Devops Knots, and there's a whole heap of stuff coming back now, which is great. So do go and check that lot out. I'll do the draw for the Knots IoT JetBrains license, which last time I looked, actually, I think was Charles and Alan Buxley. Last I looked for those 2 people. So if it does so happen that it's just you 2 that have done that, I could be wrong though. But either way, I'll check that. Then there'll be a JetBrains license winging its way to you as well. And yeah, Cliff will be on his Twitch building an actual airplane in 20 minutes. So definitely go and check that out. That'd be fantastic. To learn about that as well. So that, and so sorry to hear about the passing of Clive Sinclair. tonight. I mean, I credit where I am today and what I do to my ZX Spectrum, which the first proper computer I bought was a ZX Spectrum. So that and it's very sad news. So after Cliff's done his stream, go and watch Micro Men. It's on YouTube. I've put a link on my Twitter there. Go and check that out. Watch that. If you've not seen that before, it's a fantastic film. It's got Martin Freeman and Alexander Armstrong in it. It's a really great film, worth watching. So go and do that tonight in honour of Clive Sinclair, if nothing else. So thank you, as Johnny's just put there on his screen there. Thank you, thank Johnny for giving his talk. It's absolutely amazing. Really appreciate it. Thank you for coming along, and we'll see you if not before next month's Not IoT. See you soon,
everyone.
That's it, everyone.
Thanks.
Good night.
Bye for now.